Hello everyone and welcome to the 11th module of the Docker course. In this module, we will talk about the security features of Docker and also about logging and running the containers. First topic is about the security scanning, which are run on images to check any vulnerabilities. Image signing and Docker content trust, which is for verifying the authenticity of the images. Security and swarm communication is provided through mutual TLS or MTLS. We will also look at the logging options provided by the Docker and how to use them with containers and services. Hello everyone, in this nugget we will talk about security scanning. Docker Trusted Registry has an add-on available for Docker security scanning. It can be configured by an administrator for the DTR. It scans the images in the repositories to check if they are free from unknown security vulnerabilities or exposures. Security Scanner discovers what versions of softwares are used in the images across the layers of the image. It scans each layer and integrates the result to give a complete picture of the image. Most importantly, it correlates this information with the vulnerability database that is kept up to date through periodic updates. First, the scanner performs a binary scan on each layer of the image, identifies the software components in each layer, and indexes the SHA of each component. The scan then compares the SHA of each component against the CVE database. Scan runs either on demand when you manually start it or automatically on any Docker push to the repository. Before beginning, make sure the DTR license includes Docker security scanning and the Docker ID being used can access the download this license from the Docker store. Now let's go to the DTR setup for image scanning. On the worker1 node, I will log in as an admin credentials. To enable image scanning, go to Settings, Security and select Enable Scanning. Then select whether to use the Docker supplied CVE database online, the default option, or use a locally uploaded file offline. This option is only recommended for environments that are isolated from the internet or otherwise can't connect to the Docker or consistent updates. Once enabled in the online mode, DTR downloads the CVE database from Docker, which may take a while for the initial sync. I will enable the online syncing. It will take some time to sync, so I will just skip some part and come back here. So if you're using online mode, the DTR instance contacts a Docker server, download the latest vulnerability database and install it. Scanning can begin once the process completes. If using offline mode, then use the instructions in update scanning database offline mode to upload up an initial security database. As you can see, the sync is complete now. It shows last sync date and the time and also shows the CVE database time. I have it synced with 7.11 version of it. Once the sync is done, let's go to the repositories. We go to the details of the Nginx image as we earlier uploaded. So here now we can get the option to start the scan. I have just started the scan. It will probably take some time to finish. If you remember, we first pulled the latest version of Nginx image. We tagged it as per our username and then we pushed the same image to our DTR. So this is pretty much the latest Nginx image and the scan is running on it. It is currently in pending state and we will take some time to finish. User settings, there is an option for image scanning and we can enable or push or manual scanning. If I select on push, all the repositories are scanned while pushing. We will go to the details for the image. As you can see, the scan is done for each of the layer in the image. We can see that the scanning is still in progress. So we are back on the repositories homepage. Earlier we enabled scan on image push. So go to its details tag. The scanning is complete now and it has identified 3 critical, 25 major and 16 minor vulnerabilities. If I go to the details, It gives the summary of the on the top, and we can see the vulnerabilities for each of the layer also, right? So for the first layer has 3 vulnerabilities in that, right? Second is an empty layer, and so on, as we can see here. So as we can go on seeing, right, there's one critical empty, right? So here we saw how to do a manual scan for an already pushed image and configured scan on it. Hello everyone. In this nugget, we will learn about image signing and Docker content trust. We use the Docker engine to push and pull images to a public or private registry. In network systems, particularly over the internet, it is critical to ensure the integrity and the publisher of the images we use. This trust and authenticity is provided by the Docker content trust. It is used to digitally sign the images. Therefore, whoever pulls the image can validate whether they are getting genuine image or not. Now, Docker Trusted Registry has 2 components. One is Notary Server and Notary Signer, which run as a container. It uses the Universal Control Plane's RBAC engine, therefore no additional configuration is required. When a publisher using Docker Content Trust pushes an image to a remote registry, Docker engine signs the image locally with the publisher's private key. When a user later pulls the image, Docker engine uses the publisher's public key to verify that the image is exactly what the publisher created and has not been tampered with and is up to date. User's private key is available in the user's client bundle, which can be downloaded from the UCP. You can enable content trust by setting the Docker content trust environment variable. So let's go to one of our Docker engines to enable the content trust in a bash shell. Enter the following command: export docker content trust and equals to 1. Once set, each of the tag operations require a key for a trusted tag. A common way to consume an image is to pull it. With content trust enabled, the Docker client only allows Docker pull to retrieve signed images. Earlier, we pushed an image to the Docker hub. Let me search for that image now. I will use Docker search name of the image. Okay, so we can see that there are 3 images available here. We did not sign these images earlier. So if I try to pull these images, it should give me an error. Okay, so as expected, it gives me an error that the Notary Docker, it does not have trust data for the Docker, right? So on an environment where the content trust is set, we need to use the flag disable content trust. So I will run the same command again with disable content trust flag. Okay. So look for the image for tag 2.0 and see if we see that the download was successful. If I remove the disable content trust flag and try again, then again we get the error. UCP has a feature which will prevent untrusted images from being deployed on the cluster. Let's go to our UCP deployment and log in as admin. Okay. And the credential. Navigate to the admin settings page and in the left pane, click Docker Content Trust. Select the Run Only Signed Images options to only allow deploying applications if they use image you trust. Okay, and then save it. Right? So this is how we do signing of images and enable Docker Content Trust. In this nugget, we will talk about swarm security with MTLS. This is more like a revision as we have already covered this topic under the swarm module. When you create a swarm by running Docker swarm init, Docker designates itself as a manager node. We can either use the certificate authority of the manager node to deploy the orchestration, or we can specify external CA. The worker node and the manager node tokens include the digest of the root CA's certificate and a randomly generated secret. When a node joins a swarm, the joining node uses the digest to validate the root CA certificate from the manager node. The manager node uses the secret to ensure the joining node is an approved node. Each time a new node joins the swarm, the manager issues a certificate to the node. The certificate contains a randomly generated node ID to identify the node under the certificate common name and the role under the organizational unit. The node ID serves as the cryptographical secure node identity for the lifetime of the node in the current swarm. The nodes in the swarm use mutual transport layer security to authenticate, authorize, and encrypt the communications with other nodes in the swarm. When using the internal certificate authority, the root certificate can be rotated as well. We need to run docker swarm ca -- rotate command to generate a new CA certificate and key. Hello everyone. In this nugget, we will talk about Docker logs and logging drivers. The Docker logs command shows information logged by the running container. For that, let's go to one of our Docker hosts and we will run a container using the Tomcat image. So we will name it as Tomcat logs using the Tomcat latest image. Okay, so we will run a Tomcat log container and check the logs generated by that container. Let's check other options provided by the Docker logs command. I will run the help for Docker logs command. Okay, we see the option to see the details using the details flag. We can follow the log output using the -f option. We can also filter using the sins and tail images, and we can also see the timestamp. Similarly, Docker service logs command shows information logged by all containers participating in the service. Docker includes multiple logging mechanisms to help you get information from running containers and services. This mechanism are called logging drivers. Each Docker daemon has a default logging driver which each container uses. Default logging driver is JSON-file. The logging driver can be configured in the etc docker daemon.json. If you do not specify a logging driver, the default is JSON file. We can check the logging driver used by the container by using the docker inspect command. So docker inspect Tomcat logs and we will more it. So here we can see the log config. The type is JSON file, which is the default one. Some of the supported logging driver types are none. So if it is none, then no logs are available for the container and Docker logs does not return the output. For local, writes logs messages to the local file system in the binary files using the protobuf. Splunk writes log messages to Splunk using the HTTP event collector, and journald writes log messages to journald. The journald daemon must be running on the host machine. And syslog writes logging messages to the syslog facility. The syslog daemon must be running on the host machine, and also our JSON file which you've seen, which is the default format. There are many more logging drivers as well we can explore. Now let's change the logging driver in the daemon.json file. Okay, so let's update this file. I will configure the default logging driver as local. Okay. Need to restart the Docker service for these changes to take effect. Newly created containers take the changes. The existing containers do not update their logging driver. So run a new container for a Tomcat. Okay, so now we will run a new container for Tomcat. Call it as Tomcat logs 2, and the latest image of Tomcat. Let's inspect the container to verify the logging driver in this. Now we can see here that the logging driver type is changed to local. Run the docker logs command again. So we can also override the default logging driver specified in the daemon.json by using the -- log driver flag. So let's do that. So let's run an example where we will create another Tomcat container with the none login driver. Okay, so docker run itd, name is Tomcat log 3 this time, and then log driver we will specify is none and the Tomcat image. Okay, so now let's run the inspect command on the Tomcat logs 3. We see that the logging driver none is used for this one. In addition to using the logging drivers included with Docker, you can also implement and use logging driver plugins. We first need to install a logging driver plugin using the Docker plugin install command and then use it the way we have seen how to use it just now. So we learned about the logs provided by the Docker for the container and for the services. We also saw various options to change the logging driver for the container. Hello everyone. In this last module of this course, we will discuss some points which will help you to take the certification test. First is preparation. After taking the course and once you're done with the preparations, don't forget to take a few practice tests on the Docker Certified Associate examination. This is an important step to assess your knowledge on the subject. Second is the certification test. Certification test has 55 multiple choice questions to be done in 90 minutes. Although Docker doesn't publish the required passing score, I believe 85% would be a good score. The passing percentage, in my opinion, vary a bit on the basis of difficulty of questions presented in the test. You should target for more than 85% in the practice test before you register for the exam. In the practice test, try to identify if there is any particular domain on which you need to work more before appearing for the exam. You can then revisit that particular domain. Since there is a very small margin of error, don't leave any domain unprepared even if it constitutes just 10% of the exam. Examination. It is proctored test where there would be an instructor monitoring your activities during the exam. You will have to keep the video and audio on throughout the test duration. At the start of the exam, the instructor will check the room for the presence of any person or material which can be used in the exam. Book a time slot when you least expect the disruption. You cannot leave the room during the examination, so prepare for that. Keep a water bottle nearby in case you need to have water during the exam. Also, you would be required to show a government issued ID card at the start of the test for authentication. Questions. Most of the questions would have a single correct answer. However, there might be a few which have more than one correct answer. Even at the slow pace, you should be able to finish the exam in time, but be careful not getting stuck at any question. If you are not sure of an answer within 3 minutes, just move on to the next one. Generally, the questions would be direct, based on Docker commands or concepts. If you know the answer, well and good. Otherwise, you can try to eliminate the incorrect answers and select your best answer for the question. With this, we come to the end of this module and the Docker course. We wish you all the best of luck for your examination.